Hello, good evening, good afternoon, good morning, wherever you are. Today, we are going to be dealing with chemistry practical, the 2026 chemistry practical that we are expecting. And the questions that what we want to deal with in this video is going to be titration, or we can say the volumetric analysis or quantitative analysis. Now, we all know that chemistry practical consists of two areas that we usually treat. Number one is the volumetric analysis, which is also known as the titration, and the salt analysis, which is also known as qualitative analysis. But in this video, we are going to focus on titration, that is the volumetric analysis. Now, we all know that we all know that after we go to the lab, we do so many experiments. We work with the acid, put the acid in the burette, then put the alkali or base in the pipette, and put it in the pipette and get it to the conical flask. Apply indicator as given. Then we now try to titrate the acid against the base until we get an end point. So in this video, our video is not going to concentrate on the practical itself, but it's going to concentrate on the what is going to happen after the practical. Now, how do we present our report? How do we answer questions that are going to be related to volumetric analysis? That's what this video is going to be all about. Now, let's quickly run the let's assume that we have done the practical and want to solve the question, want to present our report to WAEC. So this video is going to give us a complete information on how we can how we can pass our chemistry practical excellently. Now let's quickly dive into the way the report is being presented. The first thing you are going to write is the volume of pipette. Now, depending on what your school provides for you, some school will have a kind of a 25 centimeter cube pipette, whereas some school is going to have a 20 cm cube pipette. Whichever one that you choose, no problem. You can just write any one of the two, depending on what the school gives to you. Now, the next one is the name of indicator. The name of indicator that we usually use is either methyl orange or phenolphthalein. So, depending on the one that they bring, that's what you are going to write. Now, the next one is the color change. Now, color change, if it is methyl orange that you are using or methyl red, you are going to have a color change of yellow to pink. That is, after you've already put your base or alkali inside the conical flask and you put your indicator, you are going to have yellow. You are going to have a yellow color. Then after you have titrated it, it will change. After you've titrated your acid against it, it will change from yellow to pink. The same thing if it is phenolphthalein, the same way. We are going to have pink, but after titrating, the pink will change to colorless. So be expecting any of the two indicator. That's how it is going to be. Now, after writing that, we are going to present a table. The table that shows the burette reading, the rough reading, the first, the second, and under this we are going to have the final burette reading, initial burette reading, and the volume of acid that is being used. Now, how do we present it? When you are presenting these values, you must ensure that your values are presented in two decimal place. Take note, your value has to be into two decimal place. Now, let's assume that we have our reading. Now, this is let's say the rough reading is something is 0 and you're having 25 here. Now, the rough reading goes as 25. And how do you get this one? You are going to subtract this one and you get the total volume of acid used. Now, if you fill up the acid again and you have maybe 0 and you have 26.50, then this one can be 26.50. Then you can also fill up your acid again. Then you have maybe 26.00, and the total volume of acid used is also 26.00. And how do you get that? You are going to be subtracting this one from each other and you get all this. Now after getting that, there is no problem. The next thing to do is to prepare your average theta value. And how do you go about that? This is what you do. You continue by saying average theta. There are two things that you can do. You can decide to add the rough and first reading and divide it by 2, or you can decide to add the first and second reading, and divide it by 2, or you add the rough, first and second reading and divide it by 3. So depending on the one that you want to do, it's okay. But for me, I'm going to add the 3 readings and find their average. Now this is 25.00 plus 26.50 and plus 26.00 all over 3. Now once I have this, then there is no problem. My average value is going to be 77.50. So it's 7.50 and divided by 3. What's going to be my answer? My answer is going to be 25.83 centimeter cube. So my average theta here is 25.8333 centimeter cube. So round it up as 25.83 centimeter cube. This one represents the volume, the average volume of acid used throughout the experiment. Now the next thing to go to is to now bring out the equation that is being used, the reagent that is being used in that question. Now in your question, there are possibilities that they will tell you that they will give the name of the acid that is used. They usually tag it as A, and your base they usually tag it as B. Now if it is the volume of acid that you want to use, now let's quickly talk about the volume of acid and the type of acid used. Now let's assume that we are using H2SO4 and we are using a base of NaOH, that is sodium hydroxide. Now let's say H2SO4 plus NaOH. Now before you write this, you are going to say that after this reading, you are going to say equation of reaction. Now you write equation of reaction and you write H2SO4 plus NaOH. Now let's quickly see whether we can balance that. Now we are going to balance it. This is the way to balance. We have Na2SO4 plus 2H2O. Yes. So we are going to have 2H2O. Now this is the balanced equation of the reaction. They might also bring HNO3. Now HNO3 also can be the acid. Then you can also balance it. It's not that hard. There is nothing to it. So I believe you know how to balance the equation. Now after that, we now say mole ratio. What's your mole ratio? The mole ratio now is equal to 1 to 2. 1 to 2. That is, the mole of acid is 1 and the mole of the base that is used, or the alkali, is 2. Now after doing that, then the next thing to do is to get yourself familiar with some questions. And what are the questions that you need to get yourself familiar with? The questions that are the normal questions that are being used in volumetric analysis. And they can easily give you some formula. And the 2 formulas that are common that we usually use for the experiment is usually this. The first one is CAVA over CBVB equals to NA over NB. Now this Ca means the concentration of the acid, and this Va means the volume of acid. Now that volume of acid is that your titer value that you got. The Ca, you will be told to calculate it. Now the Cb also, you can be told to calculate it. Then the volume of base is the volume of your burette or the volume of your pipette, sorry. Now this Na is the number of moles of acid. The equation that we did last, the number of moles of acid is 1, whereas the Nb is the number of moles of the base. So the number of moles of the base that we did the other time is 2. So let's check a question. And another formula that you need to also know before going to that question, concentration in moles per dm cube is equal to concentration in gram per dm cube all over molar mass. Now this one is also another formula that you will need while you are working with volumetric analysis. So these two formulas are very important. Once you know this one offhand, there is no question that they are going to bring on that you are not going to solve effectively. I've told you when to use this. I've told you when to use this. This concentration in grams per dm cube, they can tell you that so mass of a base. Let's look at it. That okay, let me coin up a question. Let's say 0.2 let me just say 2.5 gram of NaOH is used to titrate X mole of H2SO4. Calculate 1. Concentration of base of NaOH, in moles per dm cube. You can also say that calculate the you can tell us to calculate the concentration of H2SO4 in moles per dm cube. How do we run this one? We have already got this one, the 2.5 grams. Now you can just say it's a per dm cube. Let me just use that, per dm cube. So the calculate 2.5 gram per dm cube of NaOH is used to titrate X mole of H2SO4. Calculate the concentration of NaOH in moles per dm cube and the concentration of H2SO4 in moles per dm cube. Now, how do we go about it? It's very simple. Now, what do? We say conc in mole per dm cube equals to conc in gram per dm cube over molar mass. Now, what's the gram per dm cube of this? 2.5. And what's the molar mass? Molar mass of NaOH. Our sodium is 23. The mass of sodium is 23. The mass of sodium is 23. The mass of oxygen is 16, and that of hydrogen is 1. So this is 2.5 over 40. Our moles will be what? 0.0625 mole per dm cube. Now, we've already got our mole per dm cube. Now, thank God we have already got we've known the volume of our acid, which is the average titer. We also know the volume of our base, which is the volume of the pipette, which is 25 centimeter cube. Now, let's quickly run that concentration of H2SO4 in moles per dm cube. I can say Ca Va over Cb Vb Nb over Na. Based on what we've got the other time, we can say that what's our Ca? That's what we are looking for. The volume of acid is 25.83, and the concentration of base is 0.0625 times 25, which is the volume of acid, equal to what's the moles of the number of moles of base. Oh, sorry. The number of moles of acid is 1, and the number of moles of base is 2. Then we can easily tidy up and get our calculations from there. Now, how do we go about this? We can say that Ca equals to 0.0625 times 25 times 1 all over 2 times 25.83. So 2 times 25.83. Now, how do we get the answer? The answer is going to be, excuse me. Okay. Now the answer is 1.5625 over 1.66, and you have 0.03 mole. That's the answer. I hope you've enjoyed our video. Thank you so much, and God bless you.